The science guy. Bill Nye, the science guy. Bill Nye, the science guy.
Science rules. Nye, the science guy.
Inertia is a property of matter.
Bill Nye, the science guy. Bill Nye, the science guy. Hello, class. It's great to see all your faces. As you can tell, I got my bow tie on, so it's time for Mr. Licuria, the science guy. Mr. Licuria, the science guy. Science rules. Anyways, class, I was getting ready for bed, and you know what? It's actually 10:06 p.m. right now. I should totally be in bed. But you know what? I got this crazy idea that it's time to do a little science, do a little experimenting, so get ready to rock and roll, class. Bill Nye, the science guy. Science rules. Mr. Licuria, the science guy. I kind of like that ring a little bit more. Mr. Licuria, the science guy. Anyways, class, today in science from the PowerPoint you saw that we're actually talking about compounds, chemical compounds. We're talking about a chemical reaction. And according to my awesome textbook, it tells me chemical reaction is the process in which one or more substances are changed into one or more different substances. So what this means is we have one substance and another substance, two different elements that actually join together to create some type of new element. Sometimes you have 20 elements that join together to create a new kind of element. In the PowerPoint, we talked about how hydrogen and oxygen join together, two hydrogens, one oxygen join together to form what, you guys? Let's see, Bailey, what do they form? Two hydrogen, one oxygen. What do they form when they join together? Water, yes, H2O. In the PowerPoint, you also saw how we talked about how the color blue and the color yellow mix together to form the color green. That's in essence what we're talking about, is two actual different chemicals mixing together to form something new. And I thought a cool way for us to actually look at this would be to take one chemical we all see around our house, one actual thing we all eat, we all consume, and actually find out what's inside of it. What two chemicals are inside of it. So that's what we're going to do here today. We're actually going to test something out. And hopefully I don't catch anything. So let's begin, class. The compound we're going to be looking at actually consists of carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. It's something we eat all the time. Some of us. Some of us we do not as much. And what it is actually sugar. So before me, right here, if you look closely, is sugar. Normal sugar like you'd have in soda. Normal sugar that you use when cooking. Before me I have a lighter and candles. So let's light this and hope I catch nothing on fire. So what we are going to do is I'm actually going to put the sugar on this spoon like I have right here and put this over the flame. The sugar over the flame in the spoon, and we're going to see what happens. I want to see if we can see the hydrogen and oxygen and if we can actually see the carbon dioxide. So we are going to look at it right now. My question is, Adriana, what do you think is going to happen to this when I put it over the flame? What do you think we will see, Adriana? Go ahead. We will find out if you are right. Class, go ahead and talk about what you think you will see or we are going to see happen. You guys have 30 seconds. Alright, stop right there. Jacob, what did you decide is going to happen? I guess we'll have to find out and see. Let's see what happens. Maybe I'll move closer so we can see this better. Alright, so you can see it is over the open flame. And I've never actually tried this experiment, you guys. Let's see how long this takes. The sugar is starting to, the sucrose, also known as sugar, is starting to look a little different. But I'm not sure if you guys can tell on the video. It's starting to look a little different. Let's see, we'll give it another few seconds and see if we can see anything happening. Mr. Liquor, you're the science guy. The science guy. Never try this at home, class, but I'm going to see what it feels like. Ooh, it feels different. It is starting to feel different. It is definitely getting warm. Dun 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 dun. Let's see. I might have used too much sugar in this experiment, you guys. So it's taking a little longer than I anticipated. Okay, I see some liquid forming around the edges of it. I'm not sure if you guys can see that. But there's a little bit of liquid forming. And what that is, and it's starting to happen, is the sugar is actually starting to change from a solid to a liquid from the heat. Is actually changing physical characteristics. Instead of a solid, it is now a liquid because it is starting to heat up. Just like ice, when it is cold, is a solid, and then as it heats up, it melts and turns into a liquid, turns into water. Oh yeah, it's really starting to melt now along the edges, starting to turn into a liquid. And what this is the sugar is changing from a solid to liquid, and now it's getting so hot that it's actually, if you look close enough to it, if you actually look close enough, you can see little bubbles, and you'll see little parts of the sugar actually puff up. And that is actually gas being released. That is H2O being released. It is water. It is water being evaporated into the atmosphere, into the troposphere. See that little puff right there? That is actual H2O being released in a gas form. So you can see the sugar's gone from a liquid, from a solid I mean, to a liquid, and now it's getting so hot that some of it's actually changing into a gas. That's the H2O leaving, but something will remain, because there is carbon also in this. And the carbon should stay attached to the spoon even though it's getting so hot. You can see in the middle some of the sugar is still staying there. You can definitely see the gases, H2O gas, from the spoon actually going into the atmosphere. Now it's constantly going up. All the smoke you see coming up is coming from the spoon. So like I said, what's going up into the atmosphere is H2O. It's gas being shot off into the atmosphere because it's getting heated. It's turning into a gas. So now you can see that the sugar went from a solid to a liquid state. Now part of it is going to the gas state. It's separating the H2O from the carbon. So what's staying, the black that you see staying in the spoon, is actually carbon. That is carbon. And the smell, you guys cannot smell this, but it smells very sugary in my house. It is an interesting smell. You can see the white spot of sugar is almost all the way gone now. You can see it's really bubbling up now, class. It is really bubbling up. Definitely I would not want to touch this spoon, and this is something I would definitely not want to try at home. You guys, by yourself. Do not try this at home unless you are with an adult and they gave you permission. This is very dangerous. You can see now you can't even see the sugar. All that you see left in this spoon is the black, and that is actually the H2O. That is all that is left. I mean, the H2O has gone up, and all that is left is carbon. That is all. It's pretty amazing to think the sugar that we eat, if you heat it up, it turns into a liquid, and then the carbon stays while the hydrogen and the oxygen, the H2O, gets evaporated into the atmosphere. And you can see it's kind of puffing up now too. It's starting to go up, this carbon. Let's see what happens when we cool this down. Let's see. I don't know. Like I said, I've never done this before. So let's see what happens. Oh no. That was not supposed to happen. As you can see, compounds are in sugar. They're also in a lot of other things around our house. Everyday life, we see and consume multiple compounds, multiple chemical compounds, and maybe we'll learn a little bit more about a few other ones that we see on a regular basis. Consider the following, class. You can't learn to do any of these cool experiments if you don't read, and if you don't study science, and if you don't study math. Anyways, have a great day, and see you next time in Mr. Lucuria, the Science Guy. Science rocks. One little problem, class, with this experiment is now I have carbon stuck to my table at home, and that is not a good thing. So the next challenge for me is getting this carbon off the table.